Hello, welcome to Astronautics for Exploit. This is Dr. Ayanshola Ogundele. Water-powered spacecraft missions, validating water propulsion system for future of space missions. The focus points are as follows: water as a propellant and water-powered spacecraft missions. Since the early days of space exploration, and based on the potential benefits of using water as propellant and its availability in space, various water-based propulsion systems for powering spacecraft have been proposed. Also, several water-powered spacecraft missions have been undergone, are still in progress, and are planned. Some of the advantages of water-based propulsion are resource availability, environmentally friendly, sustainability, mass savings, high performance, and safety. Water propulsion system can help to save weight on the spacecraft propulsion system and can produce high thrust. In terms of resource availability, based on findings, water ice and its deposits are in some of the celestial bodies, and this makes water a potential fuel source for spacecraft operating in those environments. On comparison to conventional rocket fuels, water is safe to handle, and it is environmentally friendly because the combustion products of hydrogen and oxygen are primarily water vapor. Although a significant amount of energy is needed to split water into hydrogen and oxygen, and due to their low density storage of large quantities of hydrogen and oxygen could be challenging. Advantages of using water as propellant outweigh these disadvantages. Examples of water-powered spacecraft missions include Pathfinder Technology Demonstrator, Space Mission, European Spectrum Monitoring Service, Satellite Mission, Optical Communications, and Sensor Demonstration, and a host of others. Pathfinder Technology Demonstrator 1 spacecraft mission was the first to use a water-based propulsion system in space. The PTD-1 demonstrated that water fuel thrusters are safe, low cost, and high performing. Water as a propellant. Presently, research is ongoing to use water as a propellant for rockets and spacecraft. Water is a green propellant that is inexpensive, non-toxic, and stable. Future applications are water propulsion systems, which could be used for deep space exploration. Water could be produced independently on other planets or celestial bodies, and this water can be used to power spacecraft. A rendering of Figurite, an in-space orbit transfer service for satellite, is shown in this picture. Uses of water and its principle are as follows. Electrolysis. Water is broken down into hydrogen and oxygen gas using an electric current. The gases are then stored in pressurized tanks and used as fuel. Water is used to fuel a rocket, which is then launched. The water is expelled, producing thrust. Microwave electrothermal thrusting. Solar energy is used to heat water to a boil, which is then released from thrusters in order to change spacecraft orbit. Illustration of lunar water exploration concept is shown in this picture. Water-powered spacecraft missions are Pathfinder Technology Demonstrator Mission, Space Mission, ESMS Satellite Mission, Water Fuel CubeSat Mission, Equilalos Mission, Optical Communication and Sensor Demonstration Mission, Demonstrator Water Propulsion System Mission. Pathfinder Technology Demonstrator Mission is a series of missions which are planned to test the operation of a variety of novel CubeSat technologies in low Earth orbit, providing significant enhancements to the performance of small and effective spacecraft. The Pathfinder Technology Demonstrator Mission utilizes a commercial spacecraft bus and state-of-the-art avionics platform developed by Terran Orbital Corporation. Illustration of Argo spaceships powered by water that will bring things from Earth to the Moon and back again is illustrated in this picture. The PTD-1 mission was launched on January 24, 2021 to demonstrate hydrostatic propulsion system with a water-based propellant that was developed through a public-private partnership with Thales Unlimited. The PTD-1 CubeSat mission tested a water-based electrolysis propulsion system. Illustration of Pathfinder technology demonstrator 1 spacecraft, which demonstrated water-based propulsion system in low Earth orbit, is shown in this picture. The propulsion system uses power provided by the spacecraft solar arrays in order to operate miniature water electrolysis system that separates water into hydrogen and oxygen propellants by applying an electric current through the water. The demonstration tested propulsion performance through programmed thrust events, which change spacecraft velocity and altitude. Equilios mission for measuring plasma distribution is shown in this picture. Another water-powered spacecraft mission is the European Spectrum Monitoring Service satellite mission. The European and German space agencies are in cooperation with the Beijing company, RIE, and Aerospace Lab, are working on an in-flight demonstration of using water as propellant, and this is planned to be carried out by 2026. The innovative approach posed to replace propulsion systems currently in use on low and mid-Earth orbit satellites, generally fitted with chemical boosters powered by toxic products such as hydrazine. Illustration of Argo space plan to power orbital tugs with moon water is shown in this picture. The European and German space agencies are in cooperation with RIE and ERV are working on the flight demonstration of the system. Argo space mission is another water-powered spacecraft mission. Argo space spacecraft mission is aimed at creating an in-space transportation network using water-powered spacecraft. The goals are to develop reusable spacecraft that can transport satellites and payloads between orbits, to harvest water from the moon to use as propellant, to create a network of in-space transportation that can support permanent human presence beyond Earth. Illustration of Argo space plan to power orbital tugs with moon water is shown in this picture. Water-fueled CubeSat mission objectives are as follows. Demonstrate water-fuel propulsion to show that water-fuel thrusters can work in space. Increase small spacecraft mobility to make small spacecraft more capable for science and exploration missions. Test new technologies so as to verify functionality of new technologies and components in space. Develop low-cost propulsion. Use water as a propellant to reduce cost of propulsion. Use water resources in space. Apply water fuel propulsion to missions that use water resources from comets, the moon, or Mars. Illustration of Thales Alenia and Micron's water power propulsion system is shown in this picture. Equilios mission is another water-powered spacecraft mission. It's a nanosatellite of 6U CubeSat format that will measure distribution of plasma that surrounds the Earth plasmasphere to help scientists understand the radiation environment in the region. The mission is aimed at demonstrating low-thrust trajectory control techniques, such as multiple lunar flybys within the Earth-Moon region using water stem as propellant. Equilios mission for measuring plasma distribution is shown in this picture. The propulsion system called Aquarium employs 8 water thrusters, also used for altitude control and momentum management. The spacecraft carries 1.2 kg of water, and the complete propulsion system occupied about 2.5 units out of the 6 units total spacecraft volume. The waste heat from the communication components is reused to assist preheater in the water vapor production. Illustration of Equilios in moon orbit is shown in this picture. Optical communication and sensor demonstration mission is another water-powered spacecraft mission. In low Earth orbit since early December 2017, Optical Communication and Sensor Demonstration Mission is addressing two cross-cutting capabilities of value to many future small spacecraft missions: high-speed optical transmission of data and small spacecraft proximity operations. The picture here illustrates optical communications and sensor demonstration mission. The proximity sensors developed for this mission to enable relative position measurement between the two small satellites will perform a capability not previously demonstrated. The proximity operation demonstration will involve relative position measurements using cameras, beacons, laser rangefinders, and relative maneuvering using variable drag and a water-based propulsion system on board each spacecraft. Optical communication sensor spacecraft for demonstrating water propellant is shown in this picture. Demonstrator water propulsion system mission. Its primary objective is to test and validate functionality of a propulsion system that uses water as its propellant in a space environment, typically by demonstrating its ability to generate thrust through electrolysis of water, providing data on performance. The technology validation is aimed at verifying the feasibility of using water electrolysis to produce propellants. A rendering of figure right, an in-space orbit transfer service for satellite, is shown in this picture. For more information, contact Astronautics for Exploit. You've been listening to Water Power Spacecraft Missions presentation, validating water propulsion system for future for space missions, with the focus points, water as a propellant, and water power spacecraft missions. Thank you.